Hello. Once again, you are welcome to this session. Um, Today we are starting a new series titled Data Analytics with Power BI and Excel. This is not too far away from the other one of Visual Analytics. It's just a slight difference. The difference there is the Excel instead of the PowerPoint, the Python that we have on the other one. So on this one, we shall look at exactly the same set of stuff that we looked at on the other one. Overview of data analytics, the use cases, management, analysis using Excel, introduction to Power BI, and visual analytics with Power BI. So let's get on with the first one, which is overview of data analytics. What is data analytics? It's just nothing but you being able to get information from data based on whatever must have been presented in the data, to understand whatever fact is gotten from the data. How do we communicate it? How to recommend to the business what the next step should be based on what the data says. Now, talking about data, there will always be questions, and in order to answer business questions, data is required. So, how many calls were received today? How many calls were received yesterday, next day, 2 years ago, today, next year, projected data? So all these questions could be answered by using data. So, for an organization to survive, the perception has to change. To do what? To visualize what data is saying, to look at data. You cannot visualize if you don't have data. The process of visualization is just to uncover, is just to present whatever values is embedded in data. What are the origin of calls? What are the top 5 call types? How many of the calls translate to business opportunity? How many of the agents are working well? How many of the reported issues were resolved? What were the customers' major complaints? What are the new products customers are talking about? What is the perception of the product that we have launched? When are we bringing in? All these questions can be answered using data. That is the power of data analytics. Still talking about data analytics, the first process is there must be a problem. That is, you have a problem to be solved. That takes us here. That should be a business problem. In order to solve this problem, the next question will now be, do we have enough data that will take care of the response or the answer? If we do not have the data, the next step should be get the data. The data from any source should be aggregated into a repository of this nature, from where it can be visualized. Like I mentioned, you cannot visualize anything if you do not have data. So you map the data to the various questions from the business, so that when it's viewed from a business perspective. Then, because you are able to view the data, you can translate it into an insight for management attention. So when management has attention to it, then you can share the insight with the business owners. So it is the management people, the management staff, that will sell whatever idea that is being shared from data to the business owners, at the same time the process owners. So these are various visualization objects that you can think of out there. We have the bar graph, which we normally use for feature comparison for categorical data mainly. Categorical data refers to data like that is not continuous. For example, you are talking about categories of fruits. You can have different categories of colors, categories of this, categories of that. These are discrete data. We call them categorical data. So what we can do with them is just to count. So taking care of them, or getting insight from them is by the use of bar graph. So we use bar graph to say, okay, we have 20 oranges in a basket, we have 20 oranges, 10 apples, 3 Ds. Oh, in another basket we have this. So you can do a lot of comparison by using bar graph. Now you can also use bump charts or slope charts in case of bar graph. They are all doing the same thing. Then we have line graph for data that is never stable, that is never the same. It keeps changing, maybe per minute, per day, but periodically the data is changing. We use bar graph for some because you need to find out the trend. So we call that a trend line. So line graph is good for data that is temporal. Temporal in the sense that it keeps changing. So you are comparing the performance of stock for two organizations. For example, stock values changes every day. So since it changes every day, that means in 365 days, you are likely to have different values of a particular stock. So it keeps changing per day. You can compare company A and company B based on what the lines are, or the line graphs are saying, or the trends are. So we use that for things that change. Now we have scatter diagram. That is for presenting distributions. You have, for example, you have the age of students all over the place. You are comparing that with their height, and now try to put them together into a graph. So each dot represents a student. You are going to have as many students as possible. So in order to find the average age of students, you just have to agree on the line, on the direction. So this is a scatter diagram. Then we have box plot. Box plot is good when you are combining categorical data with numerical data. For example, we were talking about oranges the last time. Let's assume we decide to talk about students in a school. You will agree with me that it is not easy to say we want to treat the age of one student or the height of one student as a point. We would rather treat all of them by grouping the students into different categories, into different classes. Oh, class A, class B, class C. And even in a particular class, they are different. You cannot have them at the same age. So, in order to be able to compare their ages with their age brackets with their numbers, or the average age, you want to find out the maximum age, the minimum age, the 25th percentile, the 50th percentile, the 75th percentile. So whichever way it is, we use box plot for such. Box plot. Now comes pie chart for presenting a part of categorical data, not a whole, a part. Initially we talked about bar graph when we were talking about oranges, different oranges. But if we found out that the types of oranges available, of fruits available, they are too much, there's no point we use bar graph. We use pie chart. We can always use bar graph for such. In other words, if the numbers are not too large, then we can use pie chart. It makes a lot of sense. Now, for data that is continuous, like the age of students in the school I mentioned earlier on, and their height and the rest, you can only use histogram, because you cannot treat a student as one. You have to put them together. So, okay, between the age of 5 and 10, between the age of 10 and 20, or 10 and 15, 15 and 20, in that bucket. So you have bins in that situation. So we call that distributions. Since we have called that distribution, to represent any distribution in a graphical way, in most cases, is to use a histogram. And we can also use it for trends, just like we use line graph for trend. We can use histogram also for trend. We can use the same thing you can use box plot as also say to do the same thing. So whichever way, the box plot and the histogram will give you almost same thing. Now there's a big difference there. Box plot will give you much more information than histogram will give to you. Histogram will give you something that is not too deep. But box plot goes into the entire data and gives you a position which you can rely on at any point in time. Then we have tree map. Tree map has to do with a situation whereby you have a lot of things to present, but space is the problem. Just use tree map for it. Tree map is we use it to represent a hierarchical situation or relationship where space is a constraint. Then the last one here is heat map, which is for finding the relationship between two sets of data. You have the height of students in a school, we have their ages, so you want to find out whether there is a relationship between height and age. Heat map is a good stuff to use in that situation. And for you to make use of heat map, you have to calculate the correlation. Correlation means they are related or they are not related, or they are related negatively. So whichever way. Thank you.